Assalamualaikum. Today we're gonna present about organic chemistry, alcohol, aldehyde, and ketone. Alcohol is an organic compound that contains hydroxyl group as the functional group. There are two types of hydroxyl compound, which is aliphatic alcohol and aromatic alcohol. Aliphatic alcohol is a alkane that attached with alcohol. Aromatic alcohol is benzene that attached with alcohol. This is the example of aliphatic alcohol. This is the example of aromatic alcohol. Uh, Classification of alcohol. There are three classification of alcohol, which is primary alcohol, secondary alcohol, and tertiary alcohol. Nomenclature of alcohol. The suffix "e" in the alkane parename is replaced by "ol", and the location of OH on the longest chain is given by the smallest possible number. IUPAC rules for naming alcohol. Determine the name of parent, give the lowest number of the carbon bearing the OH group, identify substituent groups and their position, and name the alcohol. This is the example. Nomenclature of alcohol with the presence of two or more hydroxyl groups will change to diol, triol, and so on. For example, 1,2-propanediol and 1-cyclohexyl 1,3-butanediol. Naming of alcohol based on common name. Common name of alcohol is obtained by citing the name of alkyl group to which the hydroxyl group is attached and followed by the word alcohol. For example, ethyl alcohol, isopropyl alcohol, third-butyl alcohol, and cyclohexyl alcohol. Alcohol as a substituent. The hydroxyl group will become a substituent when it appears and on a structure with higher priority functional group. For example, 3-hydroxybutanoic acid and 3-hydroxycyclohexane.
Okay, next I will explain about physical properties of alcohol. First is physical state. Simple alcohol, that is the number of carbon less and equal to 12. The physical state is liquid at room temperature, colorless and volatile liquids. Example like methanol and ethanol. While alcohol that have carbon more than 12, the physical state is solids at room temperature. And phenol, the physical state is crystalline solid and corrosive, also poisonous. Alcohol's molecules are polar due to the high electronegativity of oxygen atom. Therefore, both carbon-oxygen and oxygen-hydrogen bond are polar. The polarity of alcohol's molecules provide reaction sites for many reactants and affects the physical properties of alcohols. That means some of the reaction occur at here. Polarization of oxygen and hydrogen bonds enables the alcohol molecules to form a strong hydrogen bonds to each other or with water molecules. Second is boiling points. The boiling points of alcohols are higher than alkenes or haloalkenes of similar relative molecular mass because alcohols can form intermolecular hydrogen bond between its molecules. Example like ethanol and propane, which has nearly same relative molecular mass, but ethanol has highest boiling points. This is because the existence of hydroxyl group that can form intermolecular bonds between its molecules. But alcohols with branched carbon chains with lower boiling points than straight chain molecules, even the number of carbon atoms are similar because branched alcohols have smaller surface area of contact, which is primary alcohol has the highest boiling point between secondary and tertiary alcohol. Example like here. Next, solubility. Water and alcohols have similar properties because of the presence of hydroxy groups in the molecules. The smaller alcohols, methanol, ethanol, and propanol, are completely soluble in water because it has smaller hydrophobic area, and hydrogen bonds in the molecules are formed between alcohols and water molecules. As length of the chain increases, the solubility of alcohols in water are decreased. The molecules become more like to hydrocarbons and less like water. Next is aldehydes.
So, I will present about aldehydes. Meaning of aldehydes. Chemically, an aldehyde is a compound containing a functional group with a structure CHO consisting of a carbonyl center, a carbon double bond to oxygen, with the carbon atom also bound to hydrogen and to any generic alkene or side chain R2. So the functional group of aldehydes. Aldehydes and ketones are organic compounds which incorporate a carbonyl functional group COO. The carbon atom of this group has two remaining bonds that may be occupied by hydrogen, alkyl or array substituents. If at least one of these substituents is hydrogen, the compound is an aldehyde. So this is the general formula of aldehydes. C2H2NO. So the picture there. So this is the example of structure of aldehydes, which is methanol and ethanol. This is physical properties of aldehyde. Aldehyde is polar compounds and interact in the pure state by dipole-dipole interaction, have higher boiling points and more soluble in water than nonpolar compounds of comparable molecular weight. Aldehydes have lower boiling point than the corresponding alcohol and carboxylates because aldehydes cannot form hydrogen bonds between their molecules. Aldehydes more soluble in water due to the formation of hydrogen bond with water molecule. So next we
Okay, next is a reaction of aldehyde. Reaction of aldehyde have eight reactions. So first is reduction reaction. From this reaction, aldehyde can be reduced to primary alcohol using by nickel as a catalyst at 118 degrees Celsius. So second is a triiodomethane or iodoform reaction. From this, only ethanol can form a yellow precipitate. Okay, next. Third is reaction with Grignard reagent. This reaction is about formation of alcohol. Um, First is methanol. When methanol reacts with Grignard reagent, they can form a primary alcohol, and another aldehyde reacts with Grignard reagent, they can form a secondary alcohol. Okay, next. Okay, for oxidation reaction, oxidation when aldehyde oxidize with acidified potassium manganate, they can form a carboxylic acid. And when aldehyde oxidize in alkaline solution, they can form a salt of carboxylic acid. Next. Okay, next is a Tollern reaction. Reaction with Tollern reagent. When aldehyde heat with Tollern reagent, they can form a silver mirror, as we know with argentum. Okay, the next is a reaction with Fehling solution. When aldehyde heat with Fehling solution, Cu2 plus complete ion in Fehling solution will be reduced to brick red precipitate of copper oxidized. Next. Next is oxidation reaction. Oxidation reaction is about a formation of a yellow-orange precipitate. Um, when aldehyde undergo condensation with 2,4-dinitrophenylhydrazone, they can form a 2,4-dinitrophenylhydrazine. That we know is a yellow-orange precipitate. Next, the last is about nucleophilic addition reaction. This aldehyde undergo nucleophilic addition to form a cyanohydrin by using a alkaline sodium hydroxide solution under uh, 10 to 20 degrees Celsius. So that's all. Thank you.
For ketones are formed by chemicals your liver makes. You produce them when you don't have enough insulin in your body to turn sugar or glucose into energy. You need another source, so your body use fat instead. Your liver tu- your liver turns this fat into ketones, a type of acid, and sends them into your bloodstream. They are named by finding the carbonyl group and identifying it with a location number, if necessary, then adding the suffix "-one". The common name for ketones is determined by naming the alkyl groups attached to the carbonyl in alphabetical order, then adding ketone. Next is nomenclature based on IUPAC name. Naming both alkyl groups attached to the carbonyl, then adding the suffix "-ketone". The attached alkyl group are arranged in the name alphabetically. Ketones take their name from their parent alkane chains. The ending "-e" is removed and replaced with "-one". Functional group of ketones. Ketones are carbonyl, and nomenclature of aldehydes and ketones. Aldehydes and ketones are organic compound which is incorporate a carbonyl functional group C=O. The carbon atom of this group has two remaining bonds that may be occupied by hydrogen or alkyl or aryl substituents. Uh, we prepared three of example structure of ketones, which is ester, acetoacetic acid, and beta hydroxybutyric acid.
Now I will continue the slide. What are ketones in urine? If your cell don't get enough glucose, your body burns fat for energy instead. This produces substance called ketones, which can show up in your blood and urine. High ketones level in urine may indicate diabetic ketoacidosis, a complication of diabetes that can lead a coma or even death. Next, ketones good or bad? While ketosis is a part of normal metabolism, ketoacidosis is a dangerous metabolic condition that can be fatal if left untreated. In ketoacidosis, the bloodstream is flooded with extremely high level of glucose and ketones. When this happens, the blood becomes acidic, which is seriously harmful. Ketones dangerous. Ketones upset the chemical balance of your body or of your blood, and if left untreated can poison the body. Your body cannot tolerate large amounts of ketones and will try to get rid of them through the urine. Eventually, they build up in the blood. The presence of ketones could be a sign that you are experiencing or will soon develop diabetic ketoacidosis, a life-threatening medical emergency. How do ketones affect the body? Ketones are chemicals that the body creates when it breaks down fat, fat to use for energy. The body does this when it doesn't have enough insulin to use glucose, the body's normal source of energy. When ketones build up in the blood, they make it more acidic. Lastly, ketones in blood normal range. If you do a blood ketone test, lower than 0.6 mmol per liter is a normal reading. 0.6 to 1.5 mmol per liter means you are at a slightly increased risk of diabetic ketoacidosis, and you should test again in 2 hours. Lastly, 1.6 to 2.9 mmol per liter means you are at an increased risk of diabetic ketoacidosis and should contact your diabetes team as soon as possible. Thank you.